Hi everybody, I'm Gary Simmons of the Game Institute and welcome to video 1 in the Balls of Glory development series. In this series we're going to build a complete arcade game in Unity from start to finish, including a system to support live content updates, as well as showing how to integrate the game into the Facebook ecosystem. We're even going to develop a storefront demonstrating how we can accept in-game payments when deployed to the Facebook canvas. In this video, however, we're going to talk about what the game is, the features it will support, the various stages and milestones at which we will deploy, as well as the knowledge and other requirements needed to build and host a game of this nature. Balls of Glory is a brick smashing game based on the retro arcade classic Breakout, where armed with just a ball and a paddle, you had to destroy wall upon wall of bricks. But we have moved far beyond these simple origins with our project. It has multiple levels across multiple graphical themes. It has some awesome power-ups and sound effects. Bricks, in fact, can be animated in almost any way we might imagine, and each level can be completely different from the one preceding it. And with the online patching system that we're going to develop, you can easily extend our themes or add your own completely new themes anytime you want, without recompiling or redistributing the core application. For those of you that took my older mobile training series for Unity 4, you will remember that we built an application that was the precursor to this one. It was called Balls of Steel. Even if you studied with me in that series, there is still plenty to learn from this new evolution of the game. The game was very simplistic by comparison, just a single level with an endlessly moving wall. We're going to see how we can manage asset bundles, write PHP scripts, to interface with the Facebook API, and to use MySQL databases to store user information. We're also going to write some simple custom shaders so that we can have things such as emissive bumped sprites which aren't available out of the box in Unity 5. And that's to name just a few of the things that you're going to learn. Now, having said all that, if you haven't checked out Balls of Steel, there is still some very cool stuff to learn in there too. Don't dismiss stuff just because it might not be done in the most up-to-date version of Unity. Otherwise you're going to miss out a lot of very cool stuff and some very useful knowledge that way. Balls of Glory is essentially a 3D game in which the gameplay takes place in just 2 dimensions. The paddle, the balls, the bricks and the main gaming area are all 3D objects utilizing Unity's 3D physics system. This means it benefits from Unity's 3D lighting system and the standard shader, so it's really easy to make these levels look nice and cool. The gameplay, however, takes place in 2 dimensions. The ball, the paddle, the brick are always positioned at 0 on the world's z-axis, so the game really has no spatial depth, even though the scenes in which the gameplay takes place in do. Therefore, this game could easily be implemented as a fully 2D game, if so desired. In fact, the game uses many Unity sprites for its background imagery, and in some cases for power-ups and blast effects. So, we would not say that this game fully utilizes Unity's 2D subsystems. Instead, we show how we can use much of Unity's sprite-based functionality and intersperse them seamlessly into fully 3D levels and gameplay. Now, I will provide you with all the sprite sheets used by Balls of Glory, as well as show you how I create them using tools such as Photoshop or Adobe After Effects. These include some useful techniques if you are a lone developer like me and don't have an art team at your disposal. If you are looking for a video series on how to make a pure 2D game in Unity, then do check out my Match Baker video series, where we build a Match 3 game fully utilizing Unity's 2D subsystems. Balls of Glory has many UI elements such as a high score table, social friend lists, achievement post pop-ups, and of course, an entire storefront. I like to use each of my projects to show my subscribers different ways of implementing things. In Dead Earth and Matchbaker, for example, I used Unity's new Retained Mode UI. In GI Racing, I used Unity's Immediate Mode UI system. which, while many might seem to think has been superseded by the newer retained mode UI, I would beg to differ. There are still many things that are just easier and more intuitive to do in the mono behaviors on GUI function than devising an elaborate retain mode UI and its associated events and messages. In Balls of Glory, I'm going to show yet another way that a UI could be implemented. We use neither of Unity's UI systems, but instead roll our own, using simple 3D objects, sprites, and colliders placed into the scene. Now, was this the easiest way to do it? Honestly, I don't know. I never tried to implement it any other way, but it did give me yet another opportunity to show the many ways that we can do the same thing in Unity. We will build Balls of Glory in two distinct stages. The first deployment will be a desktop application with no social integration. Now, this will allow us to build the game in its purest form and is ideal for those following along who may not have access yet to a web server or hosting space that offers PHP and MySQL functionality. The game will run completely from desktop, although even in this version we will implement our downloadable content system, so additional content in the form of asset bundles can be fetched from a server and used to update or add additional content to the game without requiring reinstallation of the application by the user. So it would be beneficial even in stage 1 to have some web hosting space at your disposal, but not crucial by any means. Now, by the end of stage 1, we're going to have a complete and playable desktop arcade game with asset bundle support and support for multiple user profiles so that you can compete against one another but on the same system. The Stage 1 application is ideal for those just starting out in Unity that have some previous programming experience in either C++, Unity Script, JavaScript, or C#. Now, the second stage of the implementation will be bringing the game to the Facebook canvas in the form of a WebGL Player. Now, at this point, you will definitely need to have some web hosting available which supports the execution of PHP scripts, which is a server-side scripting language, and also some web hosting space that allows you to set up and query a MySQL database. MySQL is a database query language that allows us to manage information stored in server-side databases. The hosting space will also be needed to host the WebGL Player that we ultimately deploy to Facebook. Now, let me just say before we continue that if you are totally new to PHP scripting or to MySQL databases, then you are advised before we get to stage 2 to either buy yourself a nice little book for beginners on both these subjects or do some tutorials online. Whilst I will show you what's involved in setting up the database tables and show you every MySQL query that I write along with every line of PHP code that I write, we are not going to be doing anything too advanced, so getting some beginner level knowledge on both PHP and MySQL should suffice and enable you to keep up. Unfortunately, this external tech is necessary as we have some processing that just must run server-side in order to keep things secure. And of course, that's vitally important once we start charging money for power-ups and additional content. If you have never done anything like this before, then this is going to be a very exciting section of the series for you. Server-side scripting, once you understand how it works, really opens up a lot of possibilities, especially with respect to social games that you might want to develop in the future. As mentioned previously, Balls of Glory contains levels that are batched by theme. Each theme is a bit like a sub-game that exists independent of the other themes. Each theme can have its own unique gameplay logic, power-ups, graphics and sound effects, and their own varying number of scenes. Balls of Glory is created initially with 3 themes. The Haunted Ruins theme takes place in a spooky graveyard-esque location with tombstones and cool thunder and lightning effects. We have swinging pendulums and rotating buzzsaws, all covered in blood in some of these levels, which work to obstruct your balls and possibly send them shooting off in unanticipated directions. Everything about the Haunted Ruins level is custom for that theme, including the use of a Unity terrain with blowing grass and custom sounds and fonts for UI messages. The Candyland theme comes with its own complete set of unique levels as well, all with custom arrangements, custom sprites and sounds, and its own version of the pendulum in the form of swinging lollipops. It also has custom puzzles that some of the other themes don't have, such as bricks that are trapped within a cage that must be unlocked before they can be destroyed, thus preventing you from completing the level until you've done so. Finally, we have the Dark City theme, set in a dystopian future city, giving us the opportunity to have some nice glowy bricks and power-ups. Once again, it has completely unique sounds, music, graphics, fonts from all of the other levels in all of the other themes. Now, if we look inside my final Balls of Glory Unity project, you can see that the various assets and levels are grouped into their own subfolders. We can see here, for example, that the Candyland theme has 15 levels. The Haunted Ruins theme here has 25 unique levels. And the Dark City theme, 15 levels. Organizing our project in this way, with all assets grouped by theme, will become clear in a moment. If we look in the build settings for the project, we might expect to see all of those scenes from all of those themes added to the build list. But in fact, the build list contains only 6 scenes. Actually, none of the themed scenes are included in the main build at all. The executable that we build will be a mere framework for hosting the themes that will be downloaded from a web server the first time the application is run, or any time thereafter if our application detects that a theme package has been changed or upgraded. Each theme, along with all its scenes and all the assets that they use and contain, will be compiled into packages called asset bundles. These bundles can be stored remotely and fetched at runtime, loaded into the game along with the graphics, sounds, fonts and scenes that they contain. Now, when the game first runs, the first thing our application will do is fetch an XML manifest from a web server. This manifest will instruct the application of all of the asset bundles, in other words, all of the theme packages that are available for download. Any that have not already been installed will become available for installation upon user's request. Any themes that are installed but have been updated will also automatically patch themselves to the latest content. Essentially, if the version number that we put in our XML manifest file on the server for that bundle is higher than the one that is already installed on the end user system, we know we have an update to do on the local machine for that theme. However, in the case where the theme bundle on the server has a version number that matches the one already installed on the client, it is not downloaded again. This means then that we only ever download anything when there is something new to add to the game or older content has been upgraded. Now, the benefits of using asset bundles for the main game content are numerous. Firstly, it means that we can add to or update our game at any time. And when we do so, every person that has installed that game will have those changes dispatched to them automatically and installed the next time they load and run our game. They don't have to visit our site, download the game again and reinstall it. Another benefit is that the executable player that we build from the Unity editor is typically going to be very small, as it doesn't contain any of the large assets such as sounds and textures, etc. Or at least it only contains those assets that are needed for startup sequences, the main menu display and closing credits. Now, this is particularly useful when deploying to mobile app stores where you typically are very limited to the core binary that you can deploy there. In such situations, the App Store can host our tiny executable, which can then download the main game content, the actual themes if you like, when the app is first executed. In fact, each theme in Balls of Glory is represented by 2 asset bundles. The main bundle contains all the scenes and resources used by that theme. These can be optionally installed by the user, as they may be sizable downloads. However, each theme also has what's called a preview bundle, which contains a graphical representation of the theme for display on the main menu. Now, when we look at the main menu in Balls of Glory, you will notice that we can see the available themes in this film strip here, and we can choose to install or play any of these themes. However, as any of these themes may not be installed currently on the system, we still need a way of letting the user know which themes are available for download on the main menu. If we add more themes, we need those themes to show up on the main menu too in their own little film strips. So even if we haven't downloaded them yet, we need to make sure that something is available graphically that our application can use to display this to the user so they can select it. Actually, each pane in this film strip here on the main menu is actually a separate preview graphic that is very small in size and exists in its own preview asset bundle. If we look in the preview folder of the Haunted Ruins theme, you can see what the preview prefab looks like for the Haunted Ruins theme. And here is the preview object for the Candyland theme. And finally, the preview object for the Dark City theme. Therefore, each theme is comprised of two bundles. The main bundle containing the entire theme, all its scenes, sounds, textures and resources, plus an additional tiny bundle, the preview bundle, that contains just one of these little preview objects. Now, how is this used? Well, if we imagine the application is running for the first time, such that the user has not yet chosen to download and install any theme, the XML manifest would tell our game all the themes that are available and the URL of the preview bundle for that theme. These preview bundles, which remember are incredibly small in size and quick to download, are always downloaded, one for each available theme. Then, on the main menu, our code instantiates the preview prefab for each theme from its respective bundle and connects them all together into this nice little scrolling film strip for user selection. Now notice this, if I simply run the main menu scene on its own in the editor without first executing the proper first scene in the sequence, which in my case is the bootstrapper scene, which is responsible for downloading the previews, then as we might imagine, no film strip is going to show up at all on the main menu. It's just a blank empty space. The first scene in our build list, and therefore the first scene that must be executed, is a scene called the bootstrapper scene. This has to be executed first because it contacts the web server, it downloads the XML manifest, and ultimately downloads and caches the various theme preview bundles for display on the main menu. Finally, we're going to have some assets which are going to be used by all themes. I call these the core game assets, and I store all of these in a mandatory bundle called the core bundle. Now this core bundle must be loaded first before any other bundles, as all those other asset bundles rely on it. If we didn't build a core bundle, then if a core graphic was used in all three themes, for example, a separate copy of that asset would be stored in each theme bundle, which is of course wasteful, although admittedly not exactly critical. But with the core bundle, we can make sure that any large assets used by multiple themes are loaded just once and accessed across theme boundaries. Facebook integration is no small task, I'll warn you now. It's not as simple as the uninitiated might think. We will need to understand the Facebook API and how to issue calls to its graph. We will need to write scripts that will handle storing users and their friends' scores and achievements in a database hosted on our own web server. We will also need to implement a secure system so that the three distributed parts of our application, that's the Unity player, the Facebook environment, and our own server-side scripts and SQL databases, can all communicate with each other without fear of hacking or cheating. Now, the application is going to be designed such that plugging in that Facebook functionality to the desktop version of the game that we build in stage 1 is going to be relatively simple. We will contain all information pertaining to the player in a class derived from an iProfile interface. Now, in the desktop version of the game, we will write a simple class called the desktop profile class, which will save scores and progress data to the hard disk, and will not implement things that are only available in the Canvas app version, such as inviting friends or purchasing products. Later, when we develop our Facebook profile class, we will be able to simply swap one for the other. The rest of the application will not care whether the profile manager being used is using a desktop profile or a Facebook profile object. The Facebook profile, instead of saving to disk, will send and retrieve data from a web server containing our PHP scripts. In fact, for added security, our client, that's our Unity player, will never issue calls directly to the Facebook graph, but instead will proxy requests through our own server-side scripts. If we wish to fetch some information from Facebook, we will make the request to our own server script first, which will then make the request to Facebook on our behalf, finally sending the resulting data that it gets back from Facebook back to the client. So because we're going to be using a single iProfile interface used by our desktop profile and our Facebook profile classes, this does mean that when developing the desktop profile in stage 1, things may appear to be coded in a slightly more complex or odd way than is otherwise required. For example, when we initialize a desktop profile object, it's going to be a completely synchronous operation. It's going to simply scan the hard disk and find all profiles on the current system, open and load in that data. However, when we initialize a Facebook profile object, it is totally asynchronous. We must launch a request to our web server, which may take several seconds to return that information to us. And even more, the web server itself will need to contact Facebook, and this request for information itself is an asynchronous operation. So the profile and the app needs to be put into a wait state in such scenarios until we know that the data has been received from the server, allowing time for the round trip. Therefore, because the iProfile interface is being used to access both desktop and Facebook profiles, certain function signatures may seem kind of odd or strange, such as the desktop profile's initialization function, which returns an IEnumerator type and must be executed as a coroutine, even though its task is basically completely synchronous. However, we must also remember that the iProfile interface is what we're going to be using to access and describe the Facebook profile object. So its initialization function needs to be asynchronous, and that's why there are cases like this where you may see us in the desktop profile implementing things as coroutines when really they just don't need to be. But you'll see later on that they do need to be when we create the Facebook version. Clearly, we have got a lot of stuff to get through, and it's a lot of very exciting stuff as well if you've never done this stuff before. So in the next video, we're going to get cracking and start building this bad boy. But remember, you should be starting to think now about investigating PHP and MySQL, so that when the time finally comes, when we start working on stage 2 of the application and bringing our game to the Facebook canvas, that you already have some basic server-side scripting knowledge under your belt, and you understand how to sort of make queries from PHP scripts to MySQL databases. So that's it for now. Thanks for listening, and I'll see you in the next video when we're going to get down to business. Bye.